Howdy everybody, welcome to Awesome JavaScript, a special holiday edition. We thank you all for coming out. I think we've got everyone really well trained for the 7:45 start time because we were sort of like sweating if anybody was going to show up, but it looks like a great crowd, so thank you. We're going to go ahead and say thank you to Spreadfast for hosting us yet again, our gracious Spreadfast hosts. And we want to say thank you to PayPal as well for sponsoring, so if you had pizza, that's thanks to them. And we'll let Steve get up and talk for a second. But before we do that, I want to briefly talk about our code of conduct. This is really a formalization of the great culture that we've had at Awesome.js. The short version is if there's something that makes you feel uncomfortable or not welcome here, please let me know. You can reach me at Loncy on Twitter. You can also DM the Awesome JavaScript Twitter account, which is the DMs are open for that, or you can hit us up on Slack. We have a Slack now. And please, if you have any questions about what the code of conduct covers, it's awesomejavascript.com, awesomejs-code-of-conduct. So, with no further ado, let's hand it over to Steve and PayPal.
Cool. Thanks. Next, it said, I used to come here. I've been coming here, so how long have you guys been around? 30 years?
Something like that, yeah.
So I've been coming around quite a bit. This is the first time I've ever been able to say we have jobs. We're actually developer.paypal.com, and I've managed to actually wrangle it so that we're going to run everything out of Austin. So I need a lot of engineers, and I need UX engineers right away, folks that understand not only like React and Less and Sass and all that stuff, but actually how to work with SVGs and stuff like that. So pretty much everything. If you've got experience, especially that's what I'm looking for right now, some senior folks to kind of start the team. Once again, UX engineers. I think that. Okay. So yeah, hit me up afterwards if you're interested. And appreciate it. Thanks for letting me speak and enjoy the pizza and beer.
Thanks again. Let's give a round of applause. I'd like to introduce our speaker, Mondo.
Hi, Lon.
Mondo is going to be telling us about an exciting new IKEA cabinetry system. Is that correct?
It's Kubernetes. Yeah.
Okay, yes. So, take it away, Mondo.
Thanks, man. So yeah, hi. My name is Mondo. I work here at Spreadfast in the operations team, and we talk about Kubernetes today. This is the first version of the talk that I gave at Awesome on Rails a couple months ago with a partner who had such a good time at that talk that she refused to ever do it again. So I had to rewrite it. So now we are Kubes for Noobs 2 Electric Kubaloo. So thank you. Thank you. Old man's unite. So just for a quick kind of gauge of the crowd, if you could please raise your hand if you've heard of Docker before. Fantastic. Keep your hands up if you have used Docker before. Great. And keep your hands up if you've heard of Kubernetes before, like outside of this talk. And how many of you have used Kubernetes? Getting lower. How many of you use Kubernetes like in anger, right? Like not just playing around. Awesome. Cool, cool, cool. All right. So I'm going to go kind of fast through the Docker portion of the talk, right? And then focus on the Kubernetes side. But if anyone has any questions, feel free to interrupt me, raise your hands, or just shout, and that's fine. So why Kubernetes, right? Why am I up here talking about this? I've been using Kubernetes here at Spreadfast for about a year now, and I am very convinced that Kubernetes, or something like it, is going to be how we deploy and manage applications in the future, right? It's just that much better than everything that I've used in the past, right? There's no more like dealing with Capistrano or Fabric or cap files or like get checkouts on a machine somewhere, right? None of that. It also does a bunch of really cool things for you kind of for free, right? It helps protect us from like super bad broken code, like not like little bugs kind of code, but like really, really bad kind of like priority one, stop the world, fucking fix it kind of problems. It also gives us some resiliency in this kind of cloud age where we live, where application servers can kind of come and go at the whim of Amazon or Google or Rackspace or whoever, right? Kubernetes gives us a little bit of hedge for that kind of stuff. Just to give a quick overview of the talk, right? We're not going to go super deep into like the operational model, like how you install it or how you run it, how you manage it. That's a way other separate talk. We're going to talk about it more from like a user perspective, how you use it day to day, right? How you kind of install things, how you get your work into Kubernetes. So I'll start this off as every other Kubernetes introduction talk goes with the Kubernetes.io definition of what Kubernetes is. Just is an open source system for automating deployment, scaling, and management of containerized applications, right? And every time I read it, I kind of feel like this, but that's okay because we know all of these words more or less, right? Like we know what automating deployment of our software means, right? Deploy our software, we want to automate it. We don't want to do it by hand. We don't want to run it from our laptops anymore. We want something else to manage that, right? We want to be able to scale our applications, right? We want to be able to say this application needs more memory, or that needs more disk, or we need more of this application. We have one of them, we want 10 of them, right? That kind of stuff. And all of this kind of magic, if you will, is unlocked by this last little bit here called containerized applications, right? And to put on my like tautology hat, a containerized application is simply an application inside of a container. Thank you. But in reality, right, like having these containers provides a standardized interface that allows Kubernetes to manage them and handle them well, right? Kubernetes doesn't care if you're running Node, it doesn't care if you're running Scala or Java or Elixir or whatever, right? All it knows is containers. And so it can run them and do whatever it's going to do with them, right? So we'll start with the containerized application and kind of work our way through the Docker world onto Kubernetes land where everything is puppies and roses. For our purposes here, we're going to containerize a small little Express app, right? How many folks here are kind of comfortable with taking a Node or Express or some kind of application and running it inside of a container, running it in Docker? Radical. Awesome. Again, if anyone does have any questions, feel free to speak up. We'll go as quickly as I got nothing else to do tonight, so take all the time in the world. These are the steps that we're going to follow, right? So we're going to make this app. We're going to containerize it, do a quick little kind of hand-wavy test, share it with the world, and then get Kubernetes to run it. So here's our application, right? Super simple little Express app. It's got a couple of endpoints, resist and who am I, that return 200 statuses with varying bodies. And then it listens to anything else and just returns a 200, right? We listen on port 3000 and we log out our hello world. So now we want to move to Docker, right? And Docker can be a little difficult to talk about because it's kind of a lot of things all packed into one thing, right? It's a runtime to run stuff. It's a specification for these like containers, right? It's a definition, like a container spec definition, right? But at the end of the day, it's just software, right? You can do a PS, look for Docker, and there's what you get, right? So it's not magic. What it does do is it runs containers, right? Takes a container and runs it. Now, Docker containers are special, right? They allow us to kind of incorporate all of the things that we need in order for our application to run, right? So in the case of our Express app, right, this container will have Node already installed on it. It will have npm installed on it. It'll have all the Node modules that we need installed on it, right? And the cool thing is that at the end of it, you have this container, this like artifact, right? Like a thing that you can run that runs your application. And if I were to give Annie the artifact, Annie could run it without having to do npm install, without having to do any rigmarole, which you wouldn't have to have JavaScript installed. It just takes a Docker container, and if she has Docker installed on her machine, it'll run, right? And again, Docker doesn't care what's inside of the container, right? It could be Rails, it could be just a Ruby script, it could be Scala, whatever. It doesn't care. So how do we get from the Express app to the Docker container? we start off with a Docker file, right? And for those who have written like make files in the past, it looks kind of similar. And the first line here says from node latest. That just means that what we're doing is we're going to start off running off of another image that someone else has built, another Docker container, right? And this Docker container has node already installed on it. And in our case, it also has npm installed on it. So we don't, in our Docker file, we don't have to install any of those things. You could, right? You could, instead of doing from node latest, you could say from Ubuntu and give you just like a bare bones Ubuntu image, and then you install everything that you want on it. This is a little bit of a shortcut. So we start from this node image, then we're copying all of our files into the image itself, right? And the files are that app.js and the like packages.json and all that stuff. Then we run npm install, which will install all of our modules into the container. Then we expose port 3000 because we said that it was going to be running on port 3000. And the last thing is the command, right? Like this is the thing that when we tell Docker to run this container, that's what it executes. npm start, right? So we've got this Docker file, and we tell Docker to build it, right? Use it to build an image. And you can see it's just running through the steps, right? Runs through the steps. If everything's okay, we have that artifact there at the end. Successfully built this SHA, this thing. That's how Docker references this container image, right? And we also give it a name, right? Resist : hello world, just like we had node : latest. Now we have another name. It's a little shortcut so we're not having to reference the SHA manually. And so if we type Docker images, sure enough, we see that we've got our image, right? There's the tag name, there's the ID, the same that we did, and the size. It's a big image, right? There's things we can do to make it smaller, but I'm not going to worry too much about that right now. So now we have our container. We can run it, right? Docker run, tell it what port it's running on, and kind of like make a bridge from that Docker container port over to our laptop on port 3000. Then we give it the name, resist hello world. And it runs, and we see the console.log output of hello world. If we do a Docker PS, it shows that it's running, right? And it tells us the command that it's running, which is npm, we hope, start, right? And it tells us which ports have been kind of bridged over. So we can run a little sanity check and do a web request to localhost, again on our laptop, because we have bridged over to port 3000/resist, and we get hello world. Ta-da. Now we have this Docker container, right, that has our code, has our application. My laptop doesn't know anything about JavaScript necessarily. It doesn't have to have Node installed or anything like that. It just runs a Docker container, right? So now that we have this container image, what we want to do is we want to share it with the world. So we put it someplace, just like we would put our code in GitHub, we can put our Docker containers in a container registry, right? Just like GitHub, where people can then pull the Docker container down and run it. Or something like Kubernetes can pull it down and run it. So to do that, we do a Docker push, and we give it a repository name, commando, and then the /resist, and then the tag hello world, and it just takes all the little bits and bytes in our container image and pushes it up. Now anyone can do a Docker pull of that image, pull it on their machine, do a Docker run, and it runs on their laptop. So now we've got our app, right? Now we want it to run in production, right? That's kind of the point of the Kubernetes part of this talk, right? So before we talk about Kubernetes, we'll talk a little bit about how we've done this over the years, right? So yeah, so I started my career back in the mid to late 90s, right? And whenever we wanted to deploy, that was kind of what everyone said, right? You got to think back to the late 90s and have an appreciation for like how simple those times were, right? This is pre-September 11th, right? You could go to the airport, like walk up to a gate without a ticket, right? DMX was like gonna give it to you at the time, right? Like that, like this was the world that we lived in, right? We were all about Perl, right? So all of our shit was written in Perl. And so I went and I wrote my cool new Perl web app. We called them web pages, right? When we cool new Perl web page, I'd call up our sysadmins, because we didn't call them ops or DevOps, we call them sysadmins, and ask her to put my code out into the world and make us, billions of dollars. And so she would call up Dell or HP or some vendor like that and buy a machine. Then they would take a couple of weeks and they would send it to her. Then she would send it to the data center. And someone at the data center would pull it off a stack and put it in a rack somewhere. And then they would call back and say, how much power is this going to use? How much network is this going to use? And we'd renegotiate our contract because now we have a new account manager, all this nonsense. And that's just to get the machine turned on, right? Then we had to install an operating system on it. Then we had to install users on it. And then we had to install Perl and Apache and then get our code on there, right? And all of this stuff was automated by some awful bash scripts that some dude wrote 2 years ago and he had since left the company and they never worked right. All in all, it took weeks to get our code up and out, right? If you're lucky, right? Probably more like months. So now, move forward to the 2000s, right? DMX has already given it to you. And the world is a much different place now, right? Here we are, post 9/11. Everyone's got cell phones, no more weird shenanigans like, oh, you went to the wrong TGI Fridays because you didn't have your cell phone. And now we're no longer doing Perl, right? We're all about J2EE now. And so we're going to get a new J2EE app out the door, right? We also don't have to call data centers and rack up hardware, right? There's this new stuff, new technology called AWS and EC2. Can you use that? There's also this new thing called Chef, right? That's supposed to automate all these processes, right? We run our Chef client on the new machines, and that's going to install all of our software. It's going to install our Java and our Tomcat and get our code out there, and everything's great. It didn't always work that way, but now what we've done is we've gone from months to weeks to getting code out, a couple of days, right? Which is super great, all in the span of 10 years. And so here we are today in the freaking desert of the real, right? We can't even what's with today. No one's got time. No one's got days to get code out, right? Everyone's busy checking Twitter and being super mad at the awfulness of the world. So now we also we've moved away from this kind of homogeneous world of monolithic architectures and stuff like that, and we're all about the microservices and developer empowerment, which is all great, but it means that now we're not running J2EE applications anymore or Perl web pages, right? We got Elixir going on, we got Scala, we got Node, we got Ruby, we got Rails, we got all this different stuff, right? So if you can get it into a container, here at Spreadfast, if you get yourself in a container, we can deploy it out to our customers to use in a matter of minutes, right? So we've gone from weeks and months to days, possibly weeks, to minutes, right? And that part is all thanks to Kubernetes. So when we talk about Kubernetes, we talk about it running in a cluster, right? In cluster mode. You can run it locally on your own machine as a single node cluster, and they have a special kind of facility for that called Minikube. But in production, you're going to run it in some configuration like this. You have one or many masters, and then many what Kubernetes calls nodes or minions, right? And they're just Linux machines, right? That's all they are, running different parts of the Kubernetes code base, right? The masters run what they call the control plane software, right? And they kind of manage the workload that is running in these pods on the nodes, right? Us as users, we submit our work as these container images, right, to the master. We tell it, run this code, and the master goes and it says, okay, well, which node has the most room, the most available resources, memory, disk, whatever, right? And then kind of balances the work across them and then watches, right? So the way that it does that is with this Kubernetes resource called a deployment, right? Take a little sidetrack here. One of my favorite things about Kubernetes is that it is declarative in nature, right? What I mean by that is like you declare the state of the world that you want to Kubernetes, and then it does its best to make that happen, right? So you tell Kubernetes, I want this image running in 6 different places in the cluster, and Kubernetes is a good friend, and it says, I got you, and it does it. And it does this through these deployments. So this is how you declare to Kubernetes that you want this, right? You create this YAML file. There's also, like, you can do it in JSON also, but most, the YAML reads easier to me, personally. So we create this deployment, right? And up at the top here, we have some metadata, give it a name, right? And we give it this label of app, and this is our resist app, right? And if you scroll down kind of the bottom, we'll see that here's that image that we just built, right? And then we tell it we want to run 2 replicas, like 2 of those little pods, right? 2 instances of this image. And this image is going to run npm start, right? And it's going to be running our Express app. Down here at the very bottom, oh, and we tell it we want it to run, or that it's going to run on port 3000, right? At the bottom, we define what's called a readiness probe. And what that does is it kind of does what it reads like, right? It's going to issue an HTTP GET to / on port 3000. And if that HTTP request returns with a 200 OK, then Kubernetes is going to say, this replica, this pod, this container is good to go. If it doesn't, for whatever reason, Kubernetes isn't going to send traffic to it. So we take this file and we run it through kube control, which is kind of the command line interface to the Kubernetes masters. We tell it to apply the state of the world, right? We're telling the Kubernetes masters, you had no idea what this deployment was before. We're telling you to now run it. And then the Kubernetes master says, all right, it's configured. We're good to go. So we do a kube control get all. We'll see that we have our deployment here, right? And it's got our desired pod. We told it to run 2 replicas, 2 pods, right? So we've got 2 available, right? And it's running the image that we told it to do, right? And down here, we have the pod names themselves. So these are our individual pods, right? They're just Docker containers running in the cluster. One of the really cool things is that you'll see here, it's running them on 2 different nodes, right? Kubernetes does its best to split your workload across multiple, these nodes that we have in the cluster here, right? It does its best to split them across there for resiliency purposes, right? If one of these nodes were to go down, right, because it's running AWS and it got killed or something crashed, something terrible happened to that node, we still have one that's running our workload, so we can still kind of field requests coming from users, right? So that's great, right? But now we need to access it, right? We just have this work running, right? It doesn't do us any good if our customers can't get to it. So to do that, we need a combination of a couple more little things, one of which is the service, right? And this is the kind of declarative definition of what a service is. And what it does is it takes those pods that we're running in the deployment and ties them together into one thing, right? And so we're telling it to look through all of Kubernetes for anything that matches this label of app resist, right? Which were our pods that were running before. And take those, combine them together, and then we do a little port rewriting. We say we had, the port that the service is listening on each individual pod is port 3000, but we want to take it and map it to port 80 for this bigger service, right? You kind of think of services almost like load balancers for your pods, right? You have as many pods as you want listening in there, and the service will take traffic coming in and then send it to each individual pod, which is super nice because if any of those pods were to die, right? Like one of those pods was on a minion that died, right? You still have all these other ones available to handle the requests. So we apply it, and now we have something new, right? Now we've got our service down here, and it's running on port 80. It's telling us which app it's using, which is our resist app, right? And it has this, this fancy cluster IP, right? And that's what lets us start to expose this service to the external world, right? And what it does, the service, the way that it knows which pod it can send data to or requests to is through that readiness probe that we defined earlier, right? So if that readiness probe is failing for whatever reason, it won't add that pod into its list of like available workers. So now we've got a deployment, right? Now we've got the service. We need to expose it to the rest of the world. And this is where things get a little hand-wavy, because the way that that actually happens is really dependent on how you run Kubernetes, right? And we're not talking a whole lot about the operational side of Kubernetes, right? So if you run this in like Google Container Engine, you're going to expose this in a totally different way than the way we do it here at Spreadfast. But I'm going to go through the way that we do it here, which is a little bit more of a manual process, right? And for that, we use something called ingress. If you're super interested about ingress, we can talk about it later at the Ginger Man or whatever. Just get me drunk and I'll tell you how terrible it is. But it's also super great. So again, right, we're following this pattern of building up these like resource definitions, these declarative definitions, telling Kubernetes to apply it, and then we go. So this ingress definition here, we give it a name, right? And then this is a special annotation that we use to determine whether or not something is accessible outside of our VPN versus something that's accessible only internally. But this is the meat of it right here, is we say any requests that come to you, ingress service, for the host resist.spreadfast.com, send it down to that service that we just created called resist on port 80, right? And so we kind of have, it's like two layers of indirection a little bit, right? So we have this ingress that sends it to the service that sends it to the pods. I guess that's three. I can't count, I just do ops. So it works, right? We do a curl to resist.spreadfast.com/resist. Hello world. We can hit that who am I endpoint, and you get the host name that it's running on. And that host name, right, is one of these pod names, right? So if you were to get onto one of these pods, like SSHN, and type host name, that's what it returns. And it's kind of cool, if you have multiple pods serving this, if you keep hitting /who am I, you'll get different host names, right, as the service load balances across the pods. So here we are, right? We have this the super cool Kubernetes cluster, right? And we have our pods, and we have our service and our ingress and our deployment and all that stuff, right? But like war, what is it good for? Not absolutely nothing, though. The reason, like, I mean, we could do this the old way, right? Like, we could just have Node installed on a machine, put our code out there, run npm and npm start, run something to like do a watchdog kind of thing, make sure it doesn't crash. But the reason that we here at Spreadfast use Kubernetes to handle all this stuff is because all of that manual work that one has to do to get these services up and running on just like a bare bones, Linux box, all that operational work can be handled for you by Kubernetes, right? If your service crashes, right, like it runs out of memory or whatever, Kubernetes will just start another one. Because of that declarative nature, we told it that we want 2 replicas running, right? So if one dies, those Kubernetes masters will see that there's only one running, and they'll start a new one, right? If that host reboots for whatever reason that you're running your stuff on, right? Someone has to go back in and turn it back on and make sure everything's running. Kubernetes handles all that for you, if a minion goes down, right? In fact, if a minion goes down, Kubernetes will see that all the work that was on that machine before, all those pods, those don't exist anymore to the Kubernetes masters. So the Kubernetes master says the state of the world has diverged from the state of the world that our users told us that it needs to be like. So it'll just start spinning up new pods, right? That can be a problem if you run your Kubernetes cluster a little too hot, right? Not enough memory, not enough CPU. If one of the minions goes down, it's going to try to start up all the work that was running on that minion. And if you don't have room for it, that can be a problem for your cluster, right? Kubernetes gives safeguards for that kind of stuff. It also protects us from ourselves, right? So here's that same Express app. And some idiot named Mondo accidentally typed blah, blah, blah at the bottom, right? And he didn't run the tests, because he never runs the tests. And he decided just to go ahead and ship it. So if you look real closely, you can see that we're going through the same process as before, right? We're taking that code, we're building a new Docker image. We just called it Hello World Busted, right? And then we push it up to Docker Hub. And then we tell Kubernetes to use it, right? The same deployment that we had before, only we changed the image name. Right? So this is how you normally deploy code into Kubernetes, right? You have your application out there, you make a change to it, you want Kubernetes to use that change, you build a new container, tell Kubernetes, use that new image, and it's going to, again, it's going to go and look at the state of the world. It's going to say, do I have 2 pods using this image? No, I have 2 pods using this old one, right? So let me spin up these 2, tear down these 2 old ones. Except Kubernetes here saves us from ourselves, right? So these 2 pods down here are not in running status. They're in error status because it failed that readiness check, right? Because npm start failed. It just can't run because of the syntax errors, right? But what Kubernetes didn't do is kill all of our old ones, right? So we still have one that's running. It's in a ready state. And the service itself that's managing taking these requests all the way down to them says the only good pod I know about is this one. So I'm just going to send requests to that one and forget these 2. So if you do a curl, it all still works just fine, right? Like that's pretty magical. So that's what Kubernetes does, right? It helps save us from ourselves. It gives us resiliency in the face of, Amazon being weird or machines dying or rebooting, that kind of stuff. It gives us the freedom as developers to kind of use languages that make us happy that might be different than what other folks in the organization are using. And it gives us the ability to iterate quickly on our designs, right? Like one of the cool things about, I read this on Twitter, I think it was last night, right? One of the cool things about Facebook's mantra of moving fast and breaking things is the other side of that coin, right? Which is, if you break things, you can move fast to fix them, right? Kubernetes lets you move super fast, right? Like in this case, it didn't break. But let's say that it had, right? Let's say that the readiness check passed for whatever reason, right? Someone's like, oh shit, it's broken. All we have to do is go back to that deployment YAML, change the image name to the old one. Kubernetes will start up 2 new pods with the old image, and everything's fine, right? Now, we had a problem, we fixed it, right? Because we rolled back in an instance, and now we can actually fix the code problem, right? We flew the plane, and now we can fix the problem, as opposed to always having to roll forward with a fix, right? Customers are happy, makes us happy. That's it. Nice and easy. Any questions?
Do we have any questions?
Yep. How often is that readiness probe?
hit the application, sir?
It's customizable. I think the default is every 10 seconds it hits it. And so there's actually two probes that you can define. You can define readiness and you can define liveliness, right? It's called a liveness probe. And the liveness probe is, if the liveness probe fails, then Kubernetes will restart the pod, right? You'll notice that these over here were in error state, right? That just means Kubernetes is like, I don't know, I can't even with this pod, I'm just gonna leave it alone, not do anything, right? So liveliness pods, the liveliness check that you write in your application, right, is useful for those kinds of transient errors that may sometimes occur, and when they do, a restart would fix them, right? And the liveness checks and the readiness checks are customizable from like a time-based percent, like how often you call it, right? And it doesn't have to be an HTTP GET either, right? Like you could have it like writing to a log file, right? And you could have the liveness check do like a cat on the log file and check for error messages in there. It's all kinds of things you can do. Random.
So obviously in real life, you're not going to manually edit your deployment YAML.
Not with that attitude, man.
We do it in a pretty naive way where we like awk and said in our GitLab stuff or in our CI scripts. We basically go through and kind of like, okay, we're going to push out this image with this like SHA, and then we're going to look that back up via like text substitution.
Sure.
I have to imagine by now there's a better way of doing that. Do you know of anything, or is that pretty much what y'all do?
So there's a couple of different things, right? We wrote our own tool to handle this kind of stuff. And at the end of the day, our tool effectively does what we just did, right? And what it does is it takes a SHA hash of your last commit on whatever branch you're in, right? Does a Docker build with that as the tag name, then a Docker push, right? So now we have latest code living in Docker Hub, right? Then it generates those service deployment ingress files, right, based on templates that we've already written, and changes the image name to use the new one that we've just made, and then does a kubectl apply, right? There are much more advanced tools like Spinnaker that help kind of manage all this stuff for you, right? Like we haven't talked at all about like having CI build your Docker images and having continuous deployment, continuous integration platforms, right? Spinnaker helps, and there are other tools like Spinnaker, right, that help manage all of this for you, right? So if you got Spinnaker like dialed in and working right, it's a lot like using Heroku, right? Like you get push, and then it goes and it runs your tests, and it builds your Docker container, deploys them out, and you can do things like canary deployments, like with that app selector, right? What you can do is you can say, like, I want the new version to be called, resist-canary, right? So it's going to have an app name of resist-canary, and you tell the service to use 30% of the pods in it need to have app-canary or app resist-canary, and the other ones just do app resist, right? So now 30% of your pods are running the new version, 70% are running your old one, right? So you can monitor your logs, you can check your honeycomb.io or whatever you use to kind of check errors, right? And you have 30% of your traffic running to the new stuff, right? 70% to your old. And then when someone goes in and gives it the big thumbs up, it pushes out the rest, right? So yeah, there are a lot of tools that you can use to kind of grease these wheels a little bit. But at the end of the day, they're all effectively doing the same kubectl apply rigmarole. Yeah, but
so Amazon, there's ECS service,
Mhm.
which is somewhat similar, just managed by Amazon.
Yes.
How do you compare them?
I've never used ECS. I've only heard the rest of the operations team here at Spreadfast complain about ECS. Ben works on our operations team and worked extensively with ECS. You want to give a compare and contrast real quick, if you can?
I think one of the biggest problems that we ended up having with ECS was, and granted, I've worked on Kubernetes for the past year and a half or so, so I don't really know how far ECS has come. But one of the biggest issues was when Mondo was up here describing services. So there's a couple different kinds of services that Kubernetes can support. What he did was something called a cluster IP. It's sort of this internal networking service mesh IP. So I couldn't go curl that IP manually unless I knew something about this service mesh. But another type of service you could do is something called a node port. So what it would do is actually go to the Kubernetes minion, Kubernetes node itself, and it will claim a port number, usually in the range of 32,000. It's just sort of Kubernetes standard at this point. And I could then curl one of the minions at that port, and it would find its way to its service. So it's a way to externally find it. ECS only supported that for us at the time. So we were limited. If you needed to run 4 of a pod, you ended up having to have 4 nodes or 4 minions running. So that was one of the limitations. We didn't have the ability to auto-scale in ECS. I believe that that's changed now. So Kubernetes has something called an HPA, it's a horizontal pod autoscaler. It scales on CPU utilization. So if someone was to let's say that resist app that Mondo wrote got really, really popular at 3 p.m. and we needed 8 of them to actually handle the traffic. Kubernetes will handle all of that for you and just spin up 8 of them because it saw a CPU spike. ECS wasn't able to handle that at the time. So we've seen Kubernetes sort of make these leaps and bounds ahead of ECS in doing the right thing. And we've seen ECS sort of trail behind. So we were primarily on ECS, and we decided to make the transition to Kubernetes, and we've been pretty happy with it. Yeah.
Thanks, my guy. Yeah, man.
Would you ever run something like a database in Kubernetes?
Would you ever run anything like a database inside Kubernetes? I mean, I wouldn't, but like that's up to you. Brandon would.
It turns out it's not. We don't run a Postgres in it but we're running persistent stuff in the. God, I forget the name. Yeah, I forget this. We're running our Elasticsearch indices and somebody currently is using Mongo in it.
Sure.
What the long-lived containers called now. I forget what they're called.
The stateful sets?
Stateful sets.
As a stateful set, yeah.
And they're happy with it. I don't feel super comfortable with that.
Yeah, I wouldn't either. And the reason I wouldn't, right, is because so Kubernetes has this idea of a stateful set, right? And it without a stateful set, these pods can move anywhere across those minions, right? And because of that, right, if a pod is running on minion A, right, and then it dies or gets restarted or whatever, for whatever reason, or you deploy, right, and Kubernetes decides to spin up the new version of that pod on minion B, right, like those disks are separate, right? So if you're running Postgres or Elasticsearch or Mongo or whatever, right, that pod has no way of finding that data that was over on the other minion, right? Kubernetes has some facilities to let you do this, right? Stateful sets in conjunction with persistent volumes, right, are one way to handle this stuff, right? Persistent volumes are you create like an EBS volume in AWS, right? And you tell Kubernetes that this pod or this set of pods or whatever is always going to use this volume, right? So if it's running on node A, minion A, and it dies and moves to minion B, what Kubernetes will say is, I can't start this pod unless it has this volume. Kubernetes will unmount that volume on node A, mount it back up on node B, and then start your pod, right? If you've ever mounted and unmounted EBS volumes in Amazon, right, you know this could take a while, right? Like on the order of like 1s and 2s of minutes, right? So it's not ideal, right? But it's also not terrible, right? You kind of have to weigh your pros and cons, right? Like, how often do you deploy Mongo, right? Probably not super often, right? So it's probably going to stay okay. If the machine, that node, that minion, right, has been up for 100, 200 days, right, then it's probably had no need to put that pod over somewhere else. It's probably okay. We've run some experiments with running data stores inside Kubernetes. We've run some data stores for like our internal like QA environments, right? And that's okay because if that data gets wiped, it just gets rebuilt later. And it's fine. I mean, they run fine, right? It's more of this kind of resiliency, and like I wouldn't run a data store that my users touch inside Kubernetes. Any other questions? Ben?
What runs Kubernetes? Like, I'm super excited. I want to try it out.
Yep.
Container, ship to Roku or Rackspace or what?
Right. So that Docker push pushes it up to Docker Hub, right? I didn't talk about like logging into Docker Hub. Docker Hub is a container registry, just like GitHub is, and if your containers are public, it lets you push as many as you want, right? So that's where the container lives, right? Kubernetes itself has to run somewhere, right? We run it in AWS and EC2, right? But you can, I mean, if you're kind of interested in the nuts and bolts of it, Kelsey Hightower, who works at Google as a dev evangelist, has this super cool repo called Kubernetes the Hard Way, right? And he walks you through spinning up a Kubernetes cluster, like pretty much by hand, right? Like you like down. So remember I was talking about like the Kubernetes software and the control plane that runs in the masters, right? Like those are just services. They're just executables, right? So you download a binary of like the API controller, and you run that, right? And on the minions, there's a binary called kubelet, and kubelet is what talks to the masters and gets work and stuff like that. And you can literally download the binary and run like /kubelet, right? And then it'll start talking. There's a lot of security involved with the Kubernetes project, right? And it does a lot of stuff with certificates to authenticate the different parts to each other, right? And so that can be a little tricky to get right, but this repo like walks you through like creating, this is how you use OpenSSL to create the cert, and you put the cert file, in etc Kubernetes, blah, 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 right? So it's a real nice kind of step-by-step process of getting a cluster up and going. If you're not interested in the nuts and bolts of getting it running, you just want to have one running, use Google Container Engine. Like they have a thing going right now where you get like $300 or $500 in free credits, right? Like for everyone, you just go and sign up, and there's literally like a make me a Kubernetes cluster button.
There's also an edX course that they just put up about.
Oh really? Like
It's meant for a preliminary for the actual Kubernetes exam.
Oh, right, for the certification exam. Nice. Oh, the edX course is free? Nice. So yeah, that sounds like would be totally another way to
I
go.
like the hardware better.
Yeah.
But the other one is much more. It's less hard.
Is it more like user focused, or is it more like operation?
Like how you discussed here.
Yeah.
And it just gets a
A little more in depth. Nice. Yeah.
But it prepares you for it if you actually want to try to pass the exam.
Be certified.
Help you get to that point where you might be able to. It's only $300.
Yeah. Yeah. So that's another thing talking about ECS, right? Like there's a lot of industry support that's been thrown behind Kubernetes, right? It's a Google project, right? But it has it's taken a big share of kind of the technology mindshare when it comes to this kind of container management and deployment management kind of stuff, right?
They
So
pushed it to the cloud.
yeah, it's part of the Cloud Native Foundation. Yeah. Which like Amazon is also now like a platinum member of the Cloud Native Foundation, right? Which makes me think that they're gonna support native Kubernetes sometime soon, right? So yeah, if you're interested in the nuts and bolts and getting it running and getting your fingers dirty, right? Kubernetes the Hard Way by Kelsey Hightower. If you just want to like do this kind of stuff and play around with it, Google Container Engine. It's super simple. It's dead simple. Yeah. I'm sorry, what was that?
Sure.
Say if some sad catastrophic event happens and your master dies in a fire, how catastrophic is that? How easy can you recover control your memories at that point? Is that a resilient scenario or is that fairly difficult?
So it's as catastrophic as you let it be, right? We run multiple masters, right? And the masters run in kind of a like a master non-master kind of setup, right? Where one master process is the leader, right? And it handles all the traffic, and then the other ones are just kind of standing by. And they use, I think, Raft to determine who is in charge, like who is the actual master, right? So if one of those masters goes down, the others will perform a leader election, and then one of them will come up, right? If you run one master and it goes down, you're still not completely blown, right? Because Kubernetes persists all of its state in etcd, right? So where every pod that is running, every mini that it's running on, all of this stuff, all of those configurations, the deployments and all that stuff, all that lives inside of an etcd cluster. That you have to set it up yourself, right? But it lives there, right? So the state isn't in memory, it's persisted out there. So if you only have one master and it goes down, if you try to do like that kubectl apply and put new work in, it won't be able to, right? Because it's not listening. And if a pod dies, right, the kubelet won't be able to talk back to the master and report back and say this thing's dead, right? And nothing is like watching the state of the world, right? So if things die, they won't restart. But the things that are running, kind of still running, right? And you're kind of still okay, right? I have a lot of favorite things about Kubernetes, but I think my super favorite thing is that you can tell that the people who wrote Kubernetes have operated stuff for a long time, right? And Kubernetes default, when it kind of doesn't know what to do or has a problem, is to like freeze and not do anything. Like, don't restart anything. Don't kill anything. Don't start anything new. Just, I don't know what to do, so chill. Don't do anything. Which is almost always what you want to have happen, right? If your master dies, your app should still be up, right? Because your app's running, right? And if your app crashes, that's something different. Right now, you got no one watching the flock. But like that should still be okay. And that's kind of how Kubernetes handles errors in general, but masters in particular. Yeah.
As an application developer, say I'm writing like a web service or something, and I plan for it eventually to run in a Kubernetes cluster.
Yep.
Are there any foot guns that I should avoid ahead of time, or like there are things I should know?
That's a good question.
To prevent myself from shooting myself in the foot.
So the things that I can think of, right, are making sure that you've got good liveness checks and readiness checks, right? Like a good readiness check, right, would do something like make sure I can talk to the database, right? If I can't talk to the database yet, I probably shouldn't come up yet, right? Or if I have to configure some things, if it takes a while for the app to come up and be ready to accept connections, right? Put that in the readiness check, right? The liveness check is a different story, right? So let's say your app can do some things without the database, right? But maybe not everything. Don't put a database check in your liveness connection or in your liveness check, right? Because what will happen is if there's a database blip, you may have written all of this nice guard code over here to be like, if database doesn't, if the database connection is down, right? Show this error state to the user, right? Sorry, please try again, right? But if a DB check is in your liveness check, Kubernetes will hit that liveness check. It'll fail because it can't talk to the database. Kubernetes will say, oh shit, right? This thing is dead. I need to restart it. Restart your pod. Now your customers are, your application is unavailable until they start back up, right? So you can do all the best practices as an app developer, but if you're not checking those, if you're not writing good liveness checks and readiness probes, right, then it kind of throws it all, it can throw all that out the window, right? Be careful writing to disk, right? Don't assume that something that you write to disk is ever going to be there, right? Because it may not if you get rescheduled, right? Like long-lived jobs, right? Probably not a great fit for Kubernetes, right? Because unless it can restart from the beginning, right? If you've got like a 10-hour job, it takes 10 hours to run every time. That pod dies in hour 9. It's going to get spun up somewhere else, probably, right? And start over. So that's really all I can think of as far as like what you should be aware of from an application perspective.
So do you ever have an issue where multiple pods, like in one case, a pod might grab a shared resource, in another case, a different pod might grab that same shared resource? I guess what I'm trying to ask is, do you find pod racing to be problematic?
No, no, I don't. I thoroughly enjoy pod racing. It's fine.
On that note,
Yeah.
let's take a break, and let's go ahead and thank Mondo again for this awesome.
Thank you, guys.